Hello everybody and welcome to this press briefing for the European State of the Climate Report 2025. It's a pleasure to have you all with us here for the next hour and a half. I'm Jeremy Wilks, I'm your host today, and I've been covering climate change issues at Euronews since 2019. We're here for the launch of the European State of the Climate, the annual flagship report published jointly by the World Meteorological Organization, WMO, and the European Centre for Medium-Range Weather Forecasts, ECMWF, which is implementing the Copernicus Climate Change Service on behalf of the European Commission. You've seen the headlines in the press release on glacier loss in Europe, the Scandinavian heatwave, record sea surface temperatures, and threats to biodiversity across the continent. So today we're going to dig deeper into the data, hearing from experts in climate science and European policymaking, and of course taking your questions on the state of the climate. Firstly, please respect the embargo. A lot of work has gone into this, so we'd like you to respect that scientific endeavour by programming all of your articles, your videos and social media posts for publication for release from 0400 hours Central European Summer Time on Wednesday, the 29th of April. This Zoom media briefing will be recorded and available on the Copernicus Press Resources page, and you can see the link in the chat. We will have the press release translated into 10 languages. Whatever form of media outlet you work for, from local newspapers to international broadcasters, everything you need should be in the online press kit, and please follow the link to download whatever you need. And in case of questions, please contact the media team at ECMWF. The email address is copernicus-press@ecmwf.int. And now let's hear from our first guests. I'm very pleased to welcome Florian Pappenberger, the Director General of ECMWF, and Celeste Saulo, the Secretary General of the World Meteorological Organization. Thanks very much for being with us here today. Florian, first question to you. We know that climate data allows organizations to gain insights and to drive change. Can you give us some new and maybe innovative examples from the past year of how Copernicus data has been used by companies and by governments?
Thank you very much for having me. It's sort of true that ECMWF and Copernicus has sort of become the backbone for weather and climate information. And these Copernicus nice insights have sort of become really day-to-day decisions. And maybe I just pick three examples. First, from the insurance sector. Generali, big insurer is using Copernicus climate change data, such as the ERA 5 analysis, to strengthen climate risk analysis. So getting a consistent climate data set. If you sort of move away from the private sector, maybe move to a humanitarian side, the UN World Food Programme is combining hazard signals with vulnerability information so that they can trigger early action and position themselves in a more favored way in case of emergencies. And then the third example, we're going to go maybe to the European Investment Bank, which sort of embeds climate and weather data into risk assessment and investment planning, so that risk is really priced in a more consistent way across infrastructure. And that is sort of where boring really matters, because none of that would work with trust and scale. Copernicus and ECMWF run exabyte scale archives. They're continuously accessed. We have stewardship and provenance above them that make these open data really usable for the real world. So Copernicus is not operational infrastructure, not just an annual report or reporting. It's used in practice.
Yeah, absolutely. It's every day. Celeste, a question for you. There's a big focus on biodiversity in the report this year. What would you say is the most important takeaway on biodiversity that you'd like to highlight to policymakers?
Thank you. Thank you very much for having me today. And as you all know, climate change is a major cause of degradation in biodiversity. And for currently, climate and biodiversity are strongly connected within European policy and frameworks. So actions are delivering results, but still progress is slow. Biodiversity and climate change are closely connected and influence each other. So climate change drives biodiversity decline, which in turn accelerates climate change. Concurrently, biodiversity resilience is the adaptive capacity of ecosystems to withstand the impacts of climate change. So increasing temperatures, changing precipitation patterns, and warming and acidifying oceans directly affect the species and ecosystem through stresses such as shrinking and moving of habitats and disruption of seasonal timing. This results in reduced species richness, degraded ecosystems, habitat loss, and higher extinction risk. Europe saw a range of extreme events throughout 2025, impacting and stressing the biodiversity of both marine and terrestrial ecosystems. For instance, I have an example in July. Subarctic Fennoscandia experienced its most severe heat wave on record, lasting 21 days and with temperatures reaching 30 degrees close to and within the Arctic cycle. But if you compare what the average tells us, this region would see 0 to 2 days of strong heat stress, and we are speaking about 21. So this had a major impact on ecosystem health. Much of subarctic Fennoscandia is classified as boreal, forest, or alpine tundra. In these biographical regions, extreme events such as heat waves and the associated droughts and fires can have significant impacts on biodiversity. For example, through degrading the habitat loss, invasive species, and promoting pest outbreaks. Prolonged heat waves may also accelerate glacier melt and alter hydrological regimes. Cold-adapted species may also shift their distributions northward or to higher elevations in response to warming, and extreme events can have detrimental effects on growth, reproduction, and survival. So the European Biodiversity Strategy 2030 aims to protect and restore biodiversity. By the end of 2025, around half of the strategy's recommended actions were in place or completed, with many of the remainder underway. So some things to reflect on.
Yeah, absolutely. And some food also for the question and answer session coming up. Another question for you, Florian. I mean, in our world, artificial intelligence is changing the way that we work so quickly. How is AI impacting ECMWF's work and Copernicus services more widely?
Well, it has been quite a week for AI, I think. Two large language models released, and then I think NOAA has actually released their first AI forecast in just a couple of weeks. Look, AI is changing science and delivery. And I think the really exciting bit is that without Copernicus, without the ERA 5 data, the entire AI weather forecasting revolution just wouldn't have scaled that fast or wouldn't even happen that fast. It's the training backbone. ECMW is already having an artificial intelligence model as a forecasting model operational alongside our physical systems. It's delivering 10 times faster, 1,000 times less of the cost. On Copernicus, this has been such a success story that we're making our data even more AI ready. We're making sure the analysis is ready, they're cloud optimized, that people spend less time on moving and wrangling data and more time on training and testing the model. This is just going so fast and it's so exciting. Just to come back, without Copernicus, without ERA 5, the entire training foundation, the entire AI weather forecast revolution would have not happened. And every single AI forecast which is out there from any company which exists is currently based on Copernicus data, which are reliable and scalable. And that is really fantastic.
Yeah, that's fascinating. Thanks for explaining that. Celeste, a question for you. We've seen this acceleration in climate change in the past decade. The 1.5 degrees target from the Paris Agreement will be passed before 2030. What action do you think is missing from policymakers and business leaders as we prepare and adapt? And is there a particular aspect of the European State of the Climate Report this year that you think they need to be paying very close attention to?
Well, as you have just mentioned, the record increase in greenhouse gases levels means that it will be virtually impossible to limit global warming to 1.5 degrees in the next few years without temporarily overshooting the Paris Agreement lower target. What is important is to keep this overshoot as short and as shallow as possible. The State of the Climate report for Europe confirms that since 1980, Europe has been warming twice as fast as the global average, making it the fastest warming continent on Earth. Heat waves are becoming more frequent and severe, and in 2025, we saw long-duration heat waves from the Mediterranean to the Arctic Circle. Southern Europe, in particular, is seeing widespread droughts fueling forest fires, and glaciers in all European regions continue to melt. Sea surface temperatures for the European Ocean region were the highest on record, and marine heat waves across Europe's seas is huge. So I think that those are the key points where we should be paying attention, and stakeholders should be closely following those results.
Thank you very much, Celeste, and we'll come back to you with the question and answer session later on. So thank you to Celeste Saulo from WMO, Florian Pappenberger from ECMWF. Now let's switch over to hear from two experts at the European Commission. And I'd like to welcome Mauro Facchini, the head of the Earth Observation Unit within the European Commission's Directorate General for Defence, Industry and Space, DG DEFIS, and Dušan Chrenek, the Principal Advisor at the European Commission's Directorate General for Climate Action, DG Klima. Thanks for being with us. Nice to see you both. Mauro, for those who are watching who are maybe new to this, can you explain the role of Copernicus in monitoring our climate, both in terms of variability and long-term change?
Okay, thank you. First check, can you hear me and see me?
All good.
Very good. So thank you very much for inviting me as representative of the European Commission as manager of the Copernicus program. It's always a pleasure to be with you, media representatives, and thank you very much ECMWF for organizing this event that is traditional, but is traditional in the sense that it's very positive because we see very good things about that, but at the same time alarming because every time we are announcing things that are quite worrying about our planet. So climate variability and change have major impacts on our daily lives. We know that, we experience that, and in different sectors from energy, transport, agriculture, food security, health, biodiversity, and so on. And it's very important to monitor climate variability and long-term changes in order to prepare us to what's happening, but also to prepare us for a resilient future. So Copernicus was established by European Union as an independent capacity, European independent capacity to provide policymakers, business people, researchers, citizens across Europe and across the world with trusted top quality insights and informed decisions. Copernicus is one of the space flagships of the European Union program, and it has been a success in the sense that beyond actually providing all this data, it has a free and open data access policy. So it's a way that everyone can take them and can really see how things are happening. And it offers unique capacities and tools to track our progress in the Paris Agreement and to accelerate our green transition. The European State of the Climate, so the one that we are speaking about today, has not become a flagship annual publication. So we consider that also with proud a good consequence of what we have done with Copernicus, and the good work of ECMWF and WMO has been presented in the previous with the previous speakers. With this new report on Europe, we learn now that almost the entire continent saw above average annual temperature, and about other records such as wildfire burn areas, fire emissions, or glacier net mass loss. But I think later on this will be better presented. And we see that actually the climate indicators, as I said before, are quite worrying. And we hope that the monitoring by Copernicus is also raising attention on that. So again, this climate service raising importance of Europe leadership in climate monitoring and to inform both about mitigation and adaptation. Over to you.
Thank you very much, Mauro. And Dušan, DG Klima, you're one of the key stakeholders in this report. Can you explain to us actually how that report is used inside the Commission to feed the conversations, maybe the policy proposals around climate change, adaptation and mitigation? Watch out for your microphone is muted.
Yeah, thanks for the invitation. And I would like to highlight that for us, the European State of the Climate Report is extremely important. European climate policy is science-based, and the European State of the Climate report is one of our most vital tools. It provides high-quality, long-term data on Europe's changing climate, from rising temperatures to negative impacts of extreme weather events. And it reinforces the urgency of both mitigation and adaptation. Inside the Commission, it plays three critical roles. First, it grounds discussion, whether on decarbonization or climate resilience, in hard facts, ensuring that policy align with the latest science. Secondly, it directly informs policy design and review, including implementation of the European climate law and climate risk management, covering wildfires, droughts, heat waves, and floods. Third, it ensures alignment across the EU. As a trusted, sure reference, it supports consistency within the Commission and with member states, stakeholders, and global partners. And beyond policymaking, it also makes climate change tangible. Copernicus data and visuals help counter misinformation and engage the public, because seeing the evidence makes the case for climate action undeniable.
Absolutely, yeah, and it's great to see that data every month coming out from C3S. Mauro, we now have the multi-annual financial framework, the famous MFF, coming up in Brussels. Everybody's talking about it. There's always a lot of competition for budgets. Can you tell us what's next for Copernicus as a whole?
Yes, thank you, Jeremy. I said I think things that are done by ECMWF, WMO, and so on are very good, but indeed, all this is requesting political decision, legal basis, and budget. So indeed, the work that is done at present is covered financially until end of next year, but the Commission is already negotiating the next 7 years with the so-called multi-annual financial framework from 2028 to 2035. And in that frame, we will move to what is the Copernicus 3.0. So again, it will be the third phases of what we are doing. And we have no lack of ideas and in order to do that. For sure, there are two priorities into that. The first is the continuity. So indeed, we have seen that we have been generating data, the reports that are done by ECMWF and so on, and we would like that this is continued in the long term in order to ensure that this data and this information is provided in a continuous way. But at the same time, we have also to step up with the changes of how world is advancing, digital things and so on. So we have to evolve in order to go even step further. And also with the launch of new satellites, because new satellites might also bring new capacities and the possibility to generate new data and new products. Last year, I would also like to say, we launched 4 satellites. This was also quite a record for us. We don't launch so many satellites per year, but 2 of them, Sentinel-4 and Sentinel-5, are very much related to the quality of our atmosphere and indeed feeding a lot these activities on climate change. But so we'll have other missions, the so-called expansion missions, coming soon towards the end of this decade. And one of these, for which we are proud, but we have still to launch them, will be the CO2 mission, with expected launch of 3 satellites, and will be the first case where we are really targeting a worldwide anthropogenic greenhouse gas emission monitoring. And indeed, we think that the contribution of this will be tremendous. So we know at the same time that EU priorities are emerging, including around competitiveness, resilience, security, defense, business innovation, and all those aspects in many sectors of the economy. For these reasons, we have already included in the next European Competitiveness Fund, sorry for the name, but it will be the legal base in which the space program will be included, a request of funding that we hope will be sufficient to ensure both the continuity of what we're doing, but also the evolution. And so I don't know if we'll have again chance to speak, but I would like to take this opportunity to congratulate and thank again ECMWF, WMO, and all the C3S team as well as contributors for summarizing this crucial 2025 climate findings for Europe. Thank you. Over to you.
Thank you very much, Mauro. And maybe a view from DG Klima, from Dušan, on a similar kind of question. What would you like to see from Copernicus? Where do you see the opportunities to kind of grow the service and make it even more relevant for policymakers?
Copernicus program is already a global benchmark for climate monitoring, providing free operational data that underpins EU policy, from emergency response to long-term planning. To make it even more decision-ready, we would like to focus on three priorities. Firstly, more precise monitoring, especially of greenhouse gases, in particular CO2, alongside land and ocean systems to better support climate action. Second, faster and more actionable information for emergencies, improving response to floods, wildfires, and storms. And thirdly, more localized resilience tools, such as city-level risk assessment with a stronger forward-looking dimension to anticipate future impacts. The goal is clear: turning world-class data into even more powerful tools to protect people, nature, and the economy. And we are already working with Copernicus on this, for example, through the European Climate Viewer, which will translate complex data into actionable insights for policymakers. This year, we are going to present our European Integrated Framework for Climate Resilience, and tools like this European Climate Viewer and digital tools in general will be part of this proposal.
Thank you very much, Dušan, and a reminder that both Mauro and Dušan will be around for the question and answer session coming up very, very soon. So thanks to Dušan Chrenek from DG Klima and Mauro Facchini from DG Defis. And now it's time for the heart of our event today, which is the presentation of the key findings from the European State of the Climate Report 2025. And this year they will be presented by both Samantha Burgess, the Strategic Lead for Climate at ECMWF, and Scannell, the Principal Meteorological Officer for Eireann, who's representing the WMO. I'll let Sam hand over to Claire when she's finished, so please take it away, Sam.
Thank you so much, Jeremy, and hopefully you can see the slides well. So the cover of this year's European State of the Climate Report is worth a moment of your attention before we get to the findings. What looks like a tree branch scattered with leaves is actually European temperature data from ERA5. Each leaf represents a year, its size telling you how far above or below normal that year's temperature was, yellow for the warm years, green for the cooler ones. Our data visualization expert took a simple scatter plot and transformed it into organic form, something that speaks to you before you've read a single word, because the warming trend and the biodiversity loss we document inside this report aren't separate stories, they're the same story. Our presentation today is just a snapshot of the report. This is the 9th edition of the European State of the Climate Report, and the 3rd edition published jointly by C3S and the World Meteorological Organization. Head to the online portal to see the full report with interactive graphics, read the summary containing key insights and stories told through a set of infographics, download a PDF of the report, explore the interactive key events map, and visit the graphics gallery complete with 142 charts and data visualizations with easy access to download high-resolution versions and the data behind the charts. The European State of the Climate 2025 is a collaborative effort of more than 100 scientists across Europe and the world, analyzing around 45 data sets to tell the story of Europe's climate in 2025. Thank you to the teams at the European Centre for Medium Range Weather Forecasts and the World Meteorological Organization, contributors to the report, dataset providers, and to the national meteorological and hydrological services across Europe for their input. Globally, 2025 was the 3rd warmest year on record, with current levels of warming global warming around 1.5 degrees above the pre-industrial level. We report that over the last 30 years, the global average temperature has been warming at around 0.27 degrees Celsius per decade. Meanwhile, Europe is warming more than twice as fast as the global average rate, making it the fastest warming continent. The 2025 report has a new section explaining why Europe and the Arctic are warming so quickly. There are several factors that contribute to this trend, including changing weather patterns, reduced air pollution, decreasing snow cover, and the proximity to the Arctic. And just as the rate of warming varies between continents, it also varies across Europe. The map here shows that the rate of warming per decade over the last 30 years, and we see that Eastern and Southeastern Europe have been warming faster than Western Europe, while Svalbard in the European Arctic is one of the fastest warming places on the planet. 2025 continued this long-term warming trend and was one of Europe's warmest years on record. This report is jointly produced by two organisations that cover overlapping but slightly different European domains. Maps showing the differences are indicated on the left-hand side of this slide. For the larger World Meteorological Organization domain, 2025 was the warmest year on record. For the C3S European domain, 2025 ranked as the third warmest year in the ERA5 dataset and the second warmest year in the EOBS dataset, which has a slightly more limited spatial coverage. The datasets are also produced differently. The EOBS dataset is interpolated from observations, and ERA5 is a reanalysis combining observations with a physical model, so some slight differences are expected. Looking at annual temperatures across Europe, the report highlights that almost the entire continent, at least 95% of the land area, saw above average annual temperatures in 2025. Parts of Northern and Eastern Europe experienced their warmest year on record, including countries amongst the United Kingdom, Norway and Iceland, while Ireland, Sweden and Finland saw their second warmest year. Sea surface temperatures also reached record highs in 2025, with the annual sea surface temperature for the European Ocean region being the highest on record for the fourth consecutive year, while the average sea surface temperature for the Mediterranean Sea was the second highest on record, slightly behind 2024. This year, for the first time, the report also includes analysis on marine heat waves, prolonged periods of unusually warm ocean temperatures, which can have widespread impacts, including on marine ecosystems, which we'll hear more from Claire later on in this presentation. Marine heatwave intensity is classified into 4 categories: moderate, strong, severe, and extreme. The proportion of the region affected by marine heatwaves has increased markedly over recent decades, from an average of 40% in the 1980s to 98% in the last 3 years. In 2025, a record 86% of the region experienced at least strong marine heatwave conditions at some point during the year, on par with 2023. For severe or extreme conditions, the proportion was 36%, also a record high and on par with the year prior, 2024. In the Mediterranean Sea, in each of the last 3 years, the entire sea experienced at least strong marine heatwave conditions, and in 2025, just over half of the sea experienced severe or extreme conditions, the third highest value after 2024 and 2023. These rising temperatures have widespread impacts. One clear impact is on Europe's cold environments and cryosphere. The area of Europe that experiences winter days with freezing temperatures is shrinking and was below average in 2025. The animation that you can see in the slide right now shows in the map, the palest blue shows the historical average area experiencing at least 14 days with a minimum temperature of 0 degrees Celsius or below for the 1961 to 1990 average, which shrinks to a smaller area for the 1991 to 2020 average, and then below average area in dark blue for 2025. Glaciers across Europe are also melting as our climate warms. The line chart on the right-hand side of this slide shows the cumulative mass change for European glaciers, highlighting clear ice loss over time. The largest glacier mass loss in 2025 was in Iceland, which saw its second largest mass loss on record. Snow cover at the end of winter in March 2025 was the third lowest on record. The snow-covered extent in March was about 1.32 million square kilometers below average, which is approximately the area of France, Italy, Germany, Switzerland, and Austria combined. A new section dedicated to reporting on the Greenland ice sheet was also introduced this year. Overall, the Greenland ice sheet lost around 139 gigatons. That's 139 billion tons of ice in 2025, which is equivalent to losing 100 Olympic-sized swimming pools every single hour. 2025 was the 29th consecutive year of net mass loss from the Greenland ice sheet, and while the number is large and represents a significant loss of ice, it was slightly below the average amount of ice lost from the ice sheet each year, which is around 152 gigatons. The ice sheet is an interconnected system of glaciers through which ice constantly moves towards the sea, driven by its own weight. At the margins, the ice flow is channeled into fast-moving outlet glaciers, which discharge ice into the ocean. The map of Greenland visualizes these ice flow dynamics, showing the ice velocity. We often directly experience climate change through changes in extreme weather, and 2025 was no exception. But beyond marine heat waves, there were heat waves from the Mediterranean to the Arctic, including Europe's second most severe heat wave on record in July. There was also widespread drought and devastating wildfires. Europe was impacted by storms and flooding, with at least 21 lives lost and at least 14,500 people affected. You can find out more about all of the events shown on this map using our interactive key events map online, with details such as the record-breaking temperatures for Western Europe for the time of year during a heat wave in June, extreme heat in southeastern Europe in July and August, during which 50 degrees or over 50 degrees was reached for the first time in Turkey, and for a number of named storms that impacted Europe, such as Storm Eireann, which impacted Ireland, the United Kingdom and Norway, and was described as by the UK Met Office as the United Kingdom's most powerful windstorm in more than a decade. One of the events examined in detail is the long heat wave that impacted subarctic Fennoscandia in July 2025. Fennoscandia is the region encompassing Norway, Sweden and Finland, and subarctic Fennoscandia refers to the region north of 60 degrees north, as shown on the map. In July 2025, subarctic Fennoscandia was impacted by its most severe heat wave on record, where severity is a combination of the duration, intensity, and area affected. The heat wave saw temperatures reaching or exceeding 30 degrees, close to and within the Arctic Circle, with several records broken for maximum temperatures and heat wave duration. While previous heat waves have reached a higher intensity, they have affected smaller areas and for much smaller durations. The July 2025 heat wave lasted a record-breaking 21 days, which is significantly longer than the previous most severe heat wave, which lasted 11 days, while in 2018, 2 heat waves affected the region in quick succession, reaching 18 days in total with a 3-day gap between the two. The heat wave also brought record levels of heat stress to the region. Typically, most of this region sees up to 2 days of strong heat stress per year, where the feels-like temperature reaches 32 degrees or more. In July 2025, a large area saw feels-like temperatures of 33 to 34 degrees Celsius, and in some locations up to 36 degrees Celsius, and up to 12 days of strong heat stress. Averaged over the region, this is the highest number of strong heat stress days on record by a large margin, almost double the previous record in 2018. While parts of southern Europe saw up to 100 to 150 days of this level of heat stress in 2025, to see almost 2 consecutive weeks of strong heat stress in subarctic Fennoscandia highlights the impact of climate change and the potential for hazardous heat in regions where it has historically been rare or non-existent. Unfortunately, Europe also experienced record-breaking wildfire activity in 2025, with both burnt area and emissions from fires reaching record levels. Fire danger was above average across most of Europe during the summer, with the highest anomalies in July and August, mainly influenced by the hot and dry conditions in southern Europe. The fire season began exceptionally early, with parts of Western Europe, including the United Kingdom and Ireland, seeing significant wildfire activity in February, and parts of Western, Central, and Eastern Europe in March and April. On the Iberian Peninsula, a shift from wet to dry conditions meant rapid spring vegetation growth died out to fuel several large wildfires in Spain and Portugal, which contributed to a larger than average burnt area for Europe. Over 1 million hectares was burnt by wildfires in 2025, with the largest contributions from fires across the Iberian Peninsula in August. Carbon emissions from wildfires in 2025 were the highest on record for Europe as a whole, and also national records for Spain, Cyprus, the United Kingdom, the Netherlands, and Germany. In recent years, European summers have seen increased wildfire potential, with a growing number of larger fires and an extended fire season. The Intergovernmental Panel on Climate Change AR6 reports that wildfire risk is likely to increase across Europe, particularly in the Mediterranean, and new wildfire-prone regions may emerge in Western, Central, and Northern Europe. Next, we examine hydrological conditions across a range of variables, including precipitation, soil moisture, lakes, river flow, and flooding. Overall, conditions in 2025 were drier than average across most of Europe, but with strong regional contrasts, as you can see on the map. For example, a large area from northwestern to eastern Europe saw below average precipitation in 2025, with annual totals 10 to 40% lower than average. In contrast, southwestern and parts of northeastern Europe saw above average precipitation. And this correlates with the fire emissions that we saw on the previous slide. These patterns were also evident in soil moisture conditions for the year, and 2025 was one of the 3 driest years for soil moisture since 1992 for Europe as a whole. In May, 35% of Europe was experiencing extreme agricultural drought. We see the same regional contrasts in annual river flow, with 70% of the European river network seeing below average annual river flows, and overall, river flow for Europe was below average for 11 months of the year. Despite the overall drier than average conditions across much of the continent, there were some significant flood events, but extreme precipitation and flooding were less widespread than in recent years. In 2025, 12% of the river network exceeded the high flood threshold, which is the second lowest flooded extent on record since 1992. The map highlights the rivers that exceeded the high or severe flood thresholds in 2025. For comparison, in 2024, 30% of the river network exceeded the high flood threshold, while 12% exceeded the severe flood threshold. According to the IPCC, precipitation trends show wetter conditions in Northern Europe and drier conditions in Southern Europe, alongside increasing frequency and intensity of extreme rainfall events. So when it rains, the rainfall is more intense, leading to more extreme impacts from flooding. And Europe is one of the regions of the world with the largest projected increase in flood risk. The contrast that we see in Europe's water and rainfall picture in 2025 are mirrored when we look at sunshine and cloud cover. Across much of Western, Central, and Eastern Europe, solar radiation was above average, while the Iberian Peninsula and parts of northeastern Europe saw less sunshine than normal. This matters beyond the weather. One of the things that this year's report examines is what climate conditions mean for our ability to generate renewable energy. And across much of the continent, the sunshine recorded translated into above average potential for solar power generation. At a time when Europe is accelerating its clean energy transition, understanding how climate variability shapes that potential year on year is exactly the kind of insight our data is here to provide. But we don't just look at climate potential. We also track what Europe actually generated. And the story here is a significant one. For the third year running, renewables produce more of Europe's electricity than fossil fuels. In 2025, they accounted for 46.4% of the continent's electricity generation. Wind and solar alone contributed 30.5%, and for the first time on record, these two sources together outproduced fossil fuel sources. This is a meaningful milestone for Europe's energy transition. Solar power had a particularly remarkable year. Its contribution to European electricity production reached a record 12.5%, up from 10.3% in 2024. And that's a combination of two factors working together: the above average sunshine conditions in 2025 and the fact that Europe continues to install more solar capacity each year. Europe is building the infrastructure of a cleaner energy system, and our climate data is showing that investment is paying off in real time. The transition is happening, it's measurable, and every year our data makes that clearer. When we look at what our observations are telling us about Europe's climate, I'm struck by how directly these changes are affecting communities, ecosystems, and the species that share this continent with us. I'll now hand over to Claire to discuss some of the key findings from the policy and action sections of the report.
Thanks, Sam. Biodiversity is vital for life on Earth. Climate change is a major cause of its degradation. Climate change and biodiversity are very closely connected and can influence and amplify one another. Rising temperatures, changing precipitation patterns, and extreme events, such as we've seen in 2025, are disrupting natural habitats. Marine environments are also under pressure as a result of warming and acidifying oceans. This decline of biodiversity weakens nature's ability to both regulate the climate and adapt to climate change, creating a reinforcing cycle. Addressing the challenges of climate change and biodiversity decline together is absolutely essential. Protecting and restoring biodiversity in a climate-smart way offers an effective nature-based approach to mitigating and adapting to climate change, while at the same time safeguarding critical ecosystems. This is reflected across Europe's climate change and biodiversity policies and initiatives. For example, the European Green Deal sets out the basis for treating climate change and biodiversity as interconnected systems. The EU climate law provides the binding framework for achieving climate neutrality and ensuring policy coherence, while the EU Restoration Law introduces binding targets to restore at least 20% of the EU's land and sea areas by 2030. These are further supported by biodiversity and climate change initiatives such as the European Biodiversity Strategy 2030, the EU Adaptation Strategy, and the European Climate Change Risk Assessment, and programmes such as Horizon Europe, BioFin, and LIFE. By the end of 2025, up to half of the European Biodiversity Strategy recommended actions were in place or completed. As you can see on the map on this slide, throughout Europe there are many examples of initiatives that aim to protect and restore biodiversity in a climate-smart way, drawing on and supported by these interconnected policies, initiatives and funding streams. And more details of all these programmes and initiatives can be found within the report. Next, we will look at two initiatives. The first, how marine heat waves are impacting marine biodiversity, and the second, how peatland wildfires are impacting biodiversity in the Netherlands. As Sam has already shown, in 2025, over 86% of European seas experienced marine heatwave conditions, and this map shows the level of marine heatwave experienced in the Mediterranean Sea, with some areas reaching levels of severe or extreme. Marine heat waves have an adverse impact on marine biodiversity. They've been linked to mass mortality events and ecosystem disruption. One species that is particularly at risk due to its sensitivity to temperatures is Posidonia oceanica, or seagrass. As shown by the blue dots on the map, this seagrass is found extensively along Mediterranean coasts. These seagrass meadows are very important. They are biodiversity hotspots housing thousands of fish per acre and are critical nursery habitats. They act as a natural barrier, buffering coastlines against erosion and storm surge. And as well as this, they act as very productive carbon sinks and can store carbon up to 30 times faster than a tropical rainforest. However, over the past 50 years, these seagrass meadows have declined by up to 34%, with climate change being one of the causes. And under high emission scenarios, this could increase to up to 75% by 2050. European policy commits members to restoring marine habitats, and these seagrass meadows are now protected under the EU Habitats Directive. This supports and facilitates the conservation of Posidonia oceanica in a climate-smart way. Over the past decade, conservation efforts centred around nature-based solutions across the Mediterranean Sea have delivered measurable benefits for biodiversity and climate resilience. Solutions such as rebedding, changes to mooring practices, and coordinated coastal planning have aided the restoration and strengthened the protection of seagrass meadows. Such conservation can serve as an effective nature-based solution, supporting both biodiversity, while also contributing to climate mitigation and adaptation. Peatlands are essential ecosystems and provide unique habitats and store large amounts of carbon. Peatland degradation and wildfires not only drive biodiversity decline, but also shift peatlands from carbon sinks to major greenhouse gas sources. Peatland wildfires can spread quickly and smoulder underground for months, making them difficult to extinguish, resulting in high mortality rates and vegetation loss, reducing habitat suitability. Europe has experienced the greatest proportional peatland loss globally. Therefore, the remaining peatlands are of high conservation importance, and many across Europe are designated as Natura 2000 sites, a status that supports the protection of active raised bog habitats in a climate-smart way. For example, wildfire risk in 2 peatland areas in the Netherlands are being mitigated through nature-based solutions. Solutions such as green fire breaks, buffer zones, ecological corridors, and mixed species reforestation have been successfully introduced to reduce fire risk while maintaining ecological integrity. Scaling up these measures is essential and is reliant on suitable ecological conditions, engaged landowners, NGO support and funding. Coordinated landscape planning and adaptive forestry are therefore essential for strengthening wildfire resilience across Europe's peatlands. And more on these 2 case studies can be found within the report. Thank you.
Thank you very much to Claire and Sam for those fascinating presentations. Really interesting to see that focus on biodiversity. We've got a ton of questions coming in. It is time for questions now. Let me welcome a new guest who's joined us to help answer some of those. That's Carlo Buontempo, the Director of the Copernicus Climate Change Service at ECMWF. Many of you know him well. And of course, usual rules apply for asking questions. Please write them into the Q&A section on this Zoom screen. Write your name and the name of your media organizations, and then go ahead with your question. Now, we've had a lot of questions about El Nino. It is not a focus of the European State of the Climate Report. However, we can hear from Celeste Saulo about El Nino. She has to leave in about 10 minutes or so, but Celeste, would you like to address some of these issues around El Nino, and then we'll dig into the European State of the Climate Report questions?
Yes, of course, Jeremy. Thank you for that question. And yes, we know that the El Nino is always a point of concern to many of us. And just to mention that the latest monthly global seasonal climate update from WMO, the link is on the chat for you to get more information, signals a clear shift in the equatorial Pacific. That means that sea surface temperatures are rising rapidly, and pointly to a likely return of El Nino conditions as early as May/July 2026. So we are concretely moving into a likely El Nino conditions. But so far, we have a level of predictability that's not so high. So we would like to wait until May to see whether this El Nino evolves into a strong El Nino or weak El Nino. And we all know the consequences. If you remember, 2024 was the warmest year on record, and that was because of El Nino. So we can expect a global warming in general because of this rise of the temperature, the rise of the temperatures on the sea. So that is what we expect, and we need to stay tuned to see the monthly updates. Thank you for that.
Thank you very much, Celeste Saulo from WMO for that on El Nino. Let's go to the first question that we had related to the European State of the Climate. Thank you to Andrea Cunha-Freitas from Publico for asking this one, who's basically saying, given all of the indicators for 2025, can Portugal be seen as an example of the worst effects of climate change in Europe? I think that one would be Sam or Carlo.
Perhaps I can start. So I think it's really important to bear in mind that with climate change, there are no winners. So yes, it's true that Portugal is in the part of Europe that is most strongly affected by climate change, especially so the area of Europe that has been impacted the most at the moment is southern and southwestern Europe. And Portugal could be considered an example of how climate change is already producing severe compound impacts in southern Europe, particularly through extreme heat, drought, and wildfires. And this reflects the broader Mediterranean region trends rather than isolated national anomalies.
Carlo, anything to add to that one?
Well, just maybe a reflection on the fact that if you look at the summer last year, especially for forest fire, it was a normal summer until it wasn't, and giving the indication on how climate change can not only exacerbate the hazard per se, but also their timing, their absolute intensity, and the switch from one state to another.
Thank you. Let's move on to a question from Victoria Seabrook from Sky News for Sam. Why is Europe becoming sunnier? The reduced aerosols, where were they coming from? And why is solar power reaching new records? And why isn't there more solar power?
A series of great questions. So one of the critical factors that is changing how sunny Europe is our improvement in air quality and the reduction in air pollution. So when we change our air quality, there are net benefits for society. It saves people's lives. People live longer when they have cleaner air to breathe, but it does come with the byproduct that when we have cleaner air, we have less of those cloud seeding aerosols that create low-level clouds. So because we have less cloud seeding pollutants in our atmosphere, it means we're getting more solar radiation hitting the surface of the Earth, particularly across Europe. And we've seen this trend. It's not a new trend. We've seen this trend since the 1980s. So since the Air Quality Act, the European Air Quality Act that has been implemented across national member states as well, emissions and therefore aerosol concentrations have reduced through time. So cloud cover has also been reduced as pollution decreases. So in 2025, solar power reached a record contribution to Europe's electricity production, as I mentioned. And that is in part due to the weather, so how sunny it was, but also in part due to our installed capacity. Capacity installation, whether it's for solar or for other forms of renewable energy, can be incredibly challenging to get through the permitting processes. And this is very much on a case-by-case basis through different member states. So I think it's always useful to understand which country you're looking at and what the barriers are, if there are any, to improving the installation capacity, not only for solar, but for other types of renewable energy.
Thank you, Sam. Very interesting. Let's move on to Stefan Eder from VDI Nachrichten in Germany. One of the key messages of the report is that annual river flow was below average in 70% of rivers. Another one for you, Sam. What does that mean for European energy production, water power, hydropower, but also for other power plants that need water for cooling, of course, like nuclear, in the sort of middle and longer term? What kind of effect does that have on our ability to build a kind of more resilient energy infrastructure in Europe?
Yeah, this is a really important question. And it is one of the challenges that we face in a warming world. So a lot of the climate-driven potential for hydropower is dependent on snowmelt. And we saw from the results of the report this year that we're getting less snow and we're getting less frost days. So we're getting less of those surges of melting snow that really create the energy in hydropower. So when we look at the contrasting conditions between northwestern and central Europe and the Iberian Peninsula in 2025, we can see the potential for run-of-river hydropower was below average from May to December last year, reflecting the below-average precipitation and river flow patterns. In contrast, however, the Iberian Peninsula saw much above average potential for run-of-river hydropower from February to September due to the above average precipitation and river flow. And just a point on the reliance of river levels for things like nuclear. We saw a couple of years ago where the nuclear power plants, particularly in France, needed to be shut off because the river levels were too low for the coolant pipes. So ensuring resilience in our energy mix in the future needs to be dependent on the climate conditions of the time. So building in the forecast of where river levels are likely to be at is incredibly important to ensure that resilience of different types of energy infrastructure.
Yeah, definitely proves the use of that data on a day-to-day basis. I've got a question from Jeremy Wilks at Radio France Internationale, who's asking, would Europe still be the fastest warming continent if we excluded the Arctic? And he follows up with 95% of the continent experienced an above average annual temperature. Is it a first or just in line with recent years? And that's either for Carlo or Sam.
Sam, go for it.
Okay. So yes, you're absolutely right that proximity to the Arctic is only one factor behind Europe's more rapid warming. The other factors include changes in atmospheric circulation, especially in summer, favoring heat waves, reduced air pollution, as we've already discussed, and reduced snow cover. So yes, if we exclude the Arctic, we would still see Europe warming at a much higher rate than the global average. Whether it's hard to forecast whether it would still be the warmest, the fastest warmest continent. Sorry, the
fastest
continent warming the fastest. The words are in the wrong order there. If we remove one of those factors, but I think the reality is we are where we are. One of the interesting findings from this report was that when we look at the 30-year climatological average, so we look at anomalies or the deviation, the change from the climate normal for the last 30 years using the 1991 to 2020 reference period, 2025 was the first time that almost the entire continent saw above average annual temperatures. And that was dependent on the data set used. So for ERA 5, it was 99%, for EOBS, it was 95%. So this shows that not only are we seeing this across Europe, but we're seeing this change in the most recent years.
Carlo, would you like to jump in?
Could do. Well, in a sense, 2024 was the warmest year on record for Europe, and most of Europe saw temperature above the same reference period, with the exception of Iceland and part of Greenland. And I think that's important because, in a sense, also shows that while the region is strongly warming overall, there is still some quite variability. And this pocket of variability where you can still have quite cold conditions are important, and are important also for adaptation purposes, because we need to adapt to a warmer continent. This doesn't mean that the risk of cold snap disappearing.
There's a lot of questions around adaptation and particularly around energy. And we have this one from Enzo Tedesco at Montel News. And he is saying, given the report's findings on drought, shrinking snowpack and stressed river systems, how significant is the risk that climate change will structurally reduce Europe's hydroelectric output over the next 5 to 10 years? And what could that mean for power prices, gas demand during peak summer and winter periods? And that one for you, Carlo.
Yeah, well, clearly the exact impact on the industry is best assessed by the industry itself, and so the impact on pricing, I think, is probably something for others to comment on. But at the same time, this reduction in the snowpack and in the ice availability, and also the change in seasonality, is already affecting the industry significantly. If you look at Northern Europe, for instance, the peak snow melt is changing with time, and this has an impact on the moment where the maximum production for hydropower is going to happen. So I would put this in the context of a general adaptation that is required in the continent to all sectors, and the hydropower, as any form of renewable, is one of the sectors where the connection with climate is more important. So, for instance, preparing for more pressure during peak demand periods, and we've seen that a couple of years ago with the drought in northern Italy, to the lack of snow in the alpine regions, and the impact it had on hydropower, but also on freshwater availability.
Thank you very much, Carlo. We have a kind of follow-up to that one from Julia Sieker from Der Standard in Austria. The report talks about above average temperature and below average precipitation that led to a significant loss of snow and ice cover. And what does this mean for the future of agriculture? And that's for Sam and Carlo.
Well, in a sense, maybe I can start, Sam, and then I'll pass it to you. But in a sense, I was alluding to it already, because it's always a nexus. It's not, we were talking about hydropower, but hydropower is not independent from freshwater availability for agricultural purposes. So losing snow means changing the hydrological cycle. It means changing the availability of water resources at peak times. And this has implication indeed for agriculture that can be very significant. So we are facing, this is one of the directions, and it's also interesting looking back at the European risk assessment, climate risk assessment that was published a couple of years ago, and a new version of which is in preparation now, because indicates a mega drought affecting Southern Europe as one of the risks we need to be aware of. Temperature going up, evaporation will go up, snowpack will decline, precipitation, especially over the Mediterranean, will not increase. So we need to prepare for something that is possibly one of the big risks of the future.
Sam, would you like to comment on that question around agriculture?
Yeah, I think One of the critical factors that we need to bear in mind is the direction of travel of the long-term trends versus the year-on-year variability. So for those who were in the room or in the audience last year, you remember that although 2024 was the warmest year on record, both globally and for Europe, it was a really wet year. So the flooding situation and the hydrological and agricultural drought situation, contrast dramatically between one year and the next. So what's really important to bear in mind is that Europe needs to be resilient for the trends that are well anticipated by the scientific community, with the caveat that those trends may not be observed within a year because of that natural variability within a system.
Absolutely. And a question here from Mia Ramo from the Finnish news agency STT, and this one's for you, Sam, again. They're working you hard today, aren't they? In Finland, we've seen recent days, lake waters, parts of Finland, the water surface of lakes is lower than usual. This is maybe a very particular question, but I would like to know more about the situation of inland waters in the Nordic countries, especially in relation to your report talking about the heat wave last summer and the Arctic areas becoming warmer?
Yeah, great question. Thank you for it. So regarding the Fennoscandia heatwave, the data in the report show that the summer saw above average lake surface water temperatures in the region. And obviously when the water, whether it's in a lake or in the ocean, when it's warmer than average, it evaporates more quickly. So a warmer lake body will end up evaporating more. So it will be a lower lake water level. The picture for lake water levels, however, for 2025 was mixed across Fennoscandia, with some seeing close to average lake levels, but some above average, and many seeing below average lake water levels. So I'd encourage you to look at the lake section of our report to look in more detail.
Thank you. And a question from Vito Tartamella from Focus magazine in Italy. What are the reasons why Europe is the fastest warming continent? What are the most urgent measures that Europe should adopt to limit the warming impact? So the first one I'll put to you, Sam, and then Dušan can come in with the second one. But what are the reasons why Europe is the fastest warming continent?
So there's four reasons which I articulated in the presentation, but it is complex, so very happy to talk through them again. So the first is geography. So parts of Europe extend into the Arctic, and the Arctic is warming at 3 to 4 times the global average rate. We also have changing weather patterns. So there are shifts in atmospheric circulation, which have favored more frequent and more intense summer heat waves. And our report highlights that the number of heat stress days is increasing, and 2025 saw extreme heat waves from the Mediterranean to the Arctic Circle. There's also reduced air pollution. So as I mentioned earlier, when we improve our air quality, we have less air pollutants or aerosols, and those aerosols seed low-level clouds, which prevents the sun's energy hitting the surface of the Earth. So clouds effectively act like a mirror. And that's why when our atmosphere was smoggier, we had less solar radiation hitting the surface of the Earth. Now that we've cleaned up our air quality, we have less of that albedo from clouds, or less of that reflectivity from clouds. So we're getting more solar radiation. And then the fourth reason is decreasing snow cover. So as temperatures increase, and they don't increase equally throughout the year, so summers are behaving differently than how they were in the past, but as our winters, and it's not a uniform change through time, it's not a uniform change between years as well. But we're really seeing reduced snow cover across Europe, and this also reduces the albedo, so this reflectivity of the white, bright surfaces. When we have less of that, we're absorbing more energy. And we see that the alpine regions of Europe are warming much faster than the European average rate as well. And over to Dušan for more information on European policy.
Thanks. And exactly the fact that Europe is warming twice as fast as other continents is worrying. And we need to act on this. And we also see that every year there are highly negative impacts of extreme weather events. Last year it was wildfires, but before floods, droughts. So every year there is something, and unfortunately we will stay with these negative impacts of extreme weather events. Therefore, we need to act in two areas. So to speed up mitigation and adaptation, both in Europe, but also internationally. On adaptation, on climate resilience, we are now working on the European Integrated Framework for Climate Resilience that we will present in the second part of this year. And our goal is to increase climate resilience in Europe to address shortages and risk. And already in 2024, European climate risk assessment pointed out risk in several areas, like also energy, health, ecosystem, agriculture, economy, and we need to address it jointly to increase our preparedness to protect people, nature, and economy. And this year report pointed out one specific area, biodiversity, but there are risks in many areas, and we need to drive transformational change to make Europe significantly better prepared for and more resilient to climate impacts. New integrated framework will empower all stakeholders to gain control in the increasingly uncertain future, and also seizing economic opportunities of climate resilience, so innovation tools, and to provide also stakeholders better data, better access. And as I mentioned earlier, with Copernicus, we are working on European Climate Viewer, which will translate high-quality data into actionable insight to policymakers. And on mitigation, we need to continue with our policies to fulfill our ambitious targets for 2030, 40, and climate neutrality and climate resilience by 2050. And we need to work with international partners because it's not only Europe. We need to work together. And for example, Commissioner Hoekstra tomorrow and on Wednesday will be in Colombia on discussing transitioning away from fossil fuel. So this is the way going forward, decarbonization and climate resilience. We need to work much harder on this.
Thank you, Dušan. Kenza Bryan from the Financial Times is asking for Carlo, can you tell us anything about the outlook for ice loss in Greenland and elsewhere in Europe in 2026?
Well, I guess this is about the report of 2025. So to really answer the question, maybe Kenza has to wait for a few months so that we produce the 2026 report. But to be fair, the report of 2025 has a bit of a mention of future long-term projections, both for Greenland ice sheet as well as for the glaciers in Europe. And I guess one of the findings is that the loss of ice mass throughout the century will continue regardless of the emission scenario that we choose. So we are facing we face a risk induced by this melting. So if you think at a local community on the coast, an increase in 1 centimeter of sea level rise expose around 6 million people across the planet to flooding risk. And if you look at, we were mentioning before, the water resources and the link of water availability to snowpack and snow melt, the loss of ice on the mountain is changing that availability. So the impact of losing basically all the glaciers, a significant part of the glaciers across Europe, has significant implication for mountain community and the like.
Thank you, Carlo. Annabelle Brockhus from Deutschlandfunk, which is the public radio in Germany, is asking to Sam. You just said the data shows the transition is happening. Can you give some examples? And also for Dušan, what are your key takeaways from this report for the European Adaptation Strategy coming later this year? Where will the priorities lie? I mean, you touched on that a little bit, Dušan, but if you would like to as well. But Sam, let's go over to you first.
Yeah, so the data shows the transition is happening. So I guess the direct example is if we go back to the animation that shows energy production across Europe, we can see that for the last 3 years we've had a greater contribution of renewable energy than fossil fuels. And so that really shows the transition, that we have more infrastructure in place to generate that renewable energy. The sun's not suddenly shining more than it was, but we need that installed capacity to harness the photovoltaic potential from the sun to transition that into electricity for Europe. So for me, that's really what we're looking at. There is a section on renewable energy within the report. There's also a additional C3S product that looks at renewable energy supply that's in partnership with ENSO-E. So perhaps Carlo could speak a little bit more about the other assets that C3S generates to really look at, in partnership with the industry, how this infrastructure is changing through time.
Dušan, would you like to come in quickly, or Carlo?
Yes, only to add that really the main finding for me is that Europe is warming much faster than other continents, that there are many risks and we need to address this risk. And the cost of inaction is significantly higher than cost of tackling negative impacts of warming climate. And that is going to be the main part of our integrated framework for climate resilience, addressing risk, and in different areas like in energy, nature, biodiversity, food. And for that, we need responsibility on all levels. And what's going to be important also to have climate resilience by design. So when we are going to build new infrastructure, new enterprises, or new policies, we need to look to the changing climate, so to have some kind forward-looking analysis and to put it in. So this climate resilience by design should be part of all policies.
Thank you, Dušan. A question from Julian Nagila from ORF in Austria. Do you see any signs that global warming has accelerated over the last 10 years, as, for example, Stefan Rahmstorff of the Potsdam Institute suggests in a recent study? That one for Sam.
Yeah, so we haven't directly looked at the changing rate in the last 10 years in the European State of the Climate Report. But when we go back to one of our other products, the Global Climate Highlights report for 2025, we stated in that the warming rate of the background climatological state increases from the late 1970s to the present day. It accelerates from 0.18 degrees per decade at the midpoint of the 30-year period, so that's 1979 to 2008, to 0.25 degrees per decade until the end of 2025. So this is in part a escalation of, a continuation of the warming trends, and then an escalation of the improvements in air quality mean we're seeing that reduction in albedo, not only in the albedo from clouds, but also in the albedo from reduced snow in the alpine and northern latitude areas of Europe, and also reduction in albedo in the Arctic and the Antarctic when we've got reduced sea ice as well.
Thank you, Sam. Another one for you from Michael Correa from Mediapart in France. Given the catastrophic state of the cryosphere in Europe, do we already know whether with rising temperatures between now and 2030/2050 or the end of the century, that will there still be any glaciers in Europe? What are the projections on that matter?
Yeah, really interesting question, and not one that I'm going to comment on, because I'm sure there are many people in this audience who enjoy winter conditions and enjoy skiing. So I don't want to create a diplomatic incident by suggesting that there may be less snow in the future. We know from a climatological perspective there will be less snow. But we already see across many alpine regions that there's artificial generation of snow. So the cryosphere is one of the ecosystems that is most impacted by climate change, and we've seen rapid shrinking throughout Europe and glaciers worldwide. There was a recent publication published by one of our European State of the Climate contributors, Mikhail Zemp, that was published in either Nature or Science a couple of weeks ago. And we had a really nice infographic last year that really looked at, I think it was something like 20 glaciers across Austria and Switzerland, and how much they'd shrunk through time. So yes, we know glaciers are shrinking, and yes, there will be a point in the future where we have significantly less glaciers across Europe. But as to the implications for those industries that rely on glaciers, we'll see how resilient and how able they are to adapt to the changing climate conditions. Carlo, Dušan, I don't know if you'd like to add anything further.
Well, maybe just to point to a piece of research that Meteo France led on a few years back, jointly with C3S, with contribution from C3S, looking at all the ski resorts in Europe and what was the impact on the snow availability for each resort, one by one, using a climate projection. And clearly, this had the conclusion of that study was that many of the resorts at lower altitude were facing significant condition, and even those at higher altitude would need to resort on sort of artificial snowmaking, and only the very top may continue to operate. So there is indeed a challenge, and a challenge that is likely to be exacerbated by climate change.
Okay, we're switching over from ice to snow, from ice and snow to fire. Now, we've got a series of questions around wildfires. Megan Rowling from Climate Home News is asking, please could you comment on how worsening wildfires are affecting Europe's greenhouse gas emissions? Also, what are the most urgent policies required to protect Europe's populations from climate change impacts?
So wildfire emissions in Europe are still relatively low in the context of total global anthropogenic carbon dioxide emissions from fires. So compared to other regions around the world, like the Americas or the tropical regions where there's not only natural wildfires, but significant burning for clearing of land, the emissions and also Arctic emissions as well. So I think it was the State of the Climate report from 2 or 3 years ago. You know, the biggest wildfire emissions for the year was those Canadian wildfires that were also known as zombie wildfires, because they kept burning below the surface in the permafrost and in the peat under the ground. So I'd really like to be able to bring Claire in on this question to talk through a little bit more on the wildfire risks, particularly to peatland habitats, because this is one of the really exciting findings from the report this year.
Thanks, Sam. So as I mentioned in the presentation, peatlands, they light very quickly and they smolder underground for a very, very long time. And this means that they're very, very, very difficult to extinguish. And as a result, because they can continue for such a long period of time, the emissions coming from them can be significant in the comparison in comparison to other wildfires, for example. And because peatlands is such a unique ecological system across Europe, it's relevant across multiple countries. Even cooler countries experience peat wildfires. We've had them here in Ireland multiple times. We've seen them occur in Iceland as well. Countries you wouldn't normally associate wildfires in, they have a huge contribution to the total emissions. I'm gonna
Yeah, thanks, Claire. We've also have another one on wildfires from Benjamin von Brackel from Süddeutsche Zeitung. He's asking what explains the record levels in wildfire burnt area and fire emissions, for example, in Germany. Sam?
Yeah, so I don't have to hand the statistics for wildfire burnt area and emissions in Germany, but the reason why we saw such critical emissions in 2025 from the Iberian Peninsula was really this transition from wet to dry. So the Iberian Peninsula, Spain and Portugal had an incredibly wet spring, and we saw that in the hydrological conditions where it was dimmer than usual. There was a lot of storms and a lot of flooding. This also meant that the vegetation in that region grew very rapidly during those spring months because it had a lot of water availability. And then when we moved into early summer, we saw record temperatures. So that vegetation that grew very rapidly then dried up very quickly. So there was a huge fuel load in the Iberian Peninsula last year that there may not have been in other years where it had been dry for several months beforehand. And it's these transitions that also create the favorable conditions. So anytime we have wildfires, it's always a combination of what the hydrological cycle has been doing, so how wet the ground is, how much moisture there's still available in the soil. And we know that drier soils enable greater wildfire risk. But also if you have a very high fuel load in addition to the wildfire weather, so hot, dry winds in particular, that's when we get these catastrophic conditions where wildfires spread very quickly, because it's likened to a tinderbox, that you have very dry, very hot conditions that enable vegetation to go up very quickly. And that's where you need to build in this resilience of, there's often a lot of dialogue about whether you need to clear that fuel load to reduce it. It's really more about the fire breaks to make sure that national parks need to be protected for biodiversity, for the ecosystem potential, but we really need those fire breaks around them to make sure that if there is a fire, it doesn't spread and it stays contained within a small area.
Thanks, Sam. And I think that to an extent actually answers the third question we had on wildfires, which was from Jonas Wacker from TAS, who was asking about where wildfires might emerge and why in the future, and counterintuitive and very fascinating business to talk about. We're going to run out of time soon, but we have a question from Laurence Thomé at AFP, who's asking, the report shows that renewables are growing fast, but Europe is still warming faster than any other continent. Has renewables deployment arrived too late to prevent near-term or long-term climate impacts? Who's going to have a go at that one? Dušan, Mauro?
Yeah, I can address this question. Fortunately, really new renewables are growing. So globally and also in Europe. And in Europe, almost half of electricity last year was produced from renewables. So that's very positive. And globally, also almost all additions in energy demand were covered by growth in renewables. But that's not sufficient. We need to speed up. And there were already commitments at global level to triple renewable energy by 2030 and also to increase energy efficiency. So renewable is not sufficient. We need to work on transitioning away from fossil fuels, electrification, and also improving integration of renewables and energy efficiency. All these areas are important for mitigation, for decarbonization, and we need to speed up. It's still not sufficient, and we will stay with impacts of warming climate and extreme weather events for many years. So at the same time, we need to adapt, we need to build climate resilience.
Thank you very much, Dušan Chrenek from DG Klima. A very clear message there to wrap up this press briefing. Thank you, everybody, for joining us for this conversation about the European State of the Climate 2025. Time is up, as I say. Many of you have asked questions that we might not have been able to answer, but please be rest assured that the ECMWF Copernicus media team will reply to you, and please contact the media team as well if you wish to organise a one-to-one interview, or if you have any other follow-up questions afterwards as well. And you can reach out to those same people if you need help with the data, clarification on a particular point of climate or atmospheric science, or issues with how to present the graphs, the maps and the charts. The email address is copernicus-press@ecmwf.int. And so all of you who've asked questions, we will get back to you, don't worry. A quick reminder again, please respect the embargo of 0400 hours Central European Summertime on Wednesday, the 29th of April. The European State of the Climate 2025 report will be launched and made public on that day. Thanks for being with us, and please stay with us for a couple of seconds more to fill out the survey. Let us know what you thought about this session, and we'll see you again soon.